Welcome. Today we discuss few problems on function. Now let us take the first problem. If fx is equal to integral part of x and gx mod of x, then the value of f of function of g of 8 by 5 minus g of f of minus 8 by 5 is options 0, 1, 2 and minus 1. Actually, it is also very simple problem, and function fx is integral part of x and gx is mod value of x, and their combination is there. We have to find its value. One thing, just I discuss one thing. If box x is given, it is actually integral part of x. So it is equal to 0 when 0 less than or equal to x less than 1. It is equal to 1 if x is 1 less than or equal to x less than 2, and so on. For positive values of x, integral part of x, actually it is the integer of that. Like say if x is lies between 0 and 1, so it is equal to something like that, say 0.81. Its box function, it is equal to 0. Now for if actually x is any negative number, then it is of the type, say, for minus 1 less than or equal to x less than 0. In that case, it is equal to minus 1. If minus 2 less than or equal to x less than minus 1, then it is equal to minus 2. That is, if x is negative, if x is negative, then this is the case. So with this information, this problem can be solved very easily. This is actually equal to g of 8 by 5. G means modulus. So it is f of modulus of 8 by 5, simply 8 by 5, minus now g of f of minus 8 by 5. F means fx is integral part of x. It is equal to minus 8 by 5 box, that is minus 1 point something, 8336, something like that. So it lies between minus 1 and minus 2. So minus 2 and minus 1 of that type. So its value will be minus 2. So that g of f of minus that is minus 2. So that it is equal to f of 8 by f means functional value of 8 by 5. It is equal to its value is 1 point. Its value is 1 point something. So it is simply 1. Lies between in that case, minus g of x means modulus value of minus 2, so that it is equal to 1 minus, this is plus 2, 1 minus 2 minus 1. So that option 4 is correct. Now, our next problem. If f of x plus 2y minus x minus 2y is equal to x into y, then value of f x comma y, its option is 1/4 x y. Second option is 1/4 x square minus y square. 1/8 x square minus y square. Half of x square plus y square. That problem was given in WBJEE in the year 2011. It's a very simple problem. It is f is a function of two variables. One variable is this, other variable is that. But this variable is again a function of x and y. This second variable is again another function of x and y. From there, you have to find function of x and y. For that purpose, let us take x plus y, 2y, this one. X plus 2y is equal to u, and x minus 2y is equal to v. Now solve for x and y in terms of u and v. Adding them, 2x is equal to u plus v. Cancels. 2x is equal to u plus v. So x is equal to half of u plus v. And if x is equal to that, subtracting we get 4y, this minus that, x cancels, 4y is equal to u minus v. That is, y is equal to that. Now, we get the function is that. Now, convert xy in terms of u and v, so that this is equal to x of, this is equal to u plus, this is u comma v is equal to x into y. Now convert x and y in terms of u and v, so that their product is equal to 1/8 into u square minus v square, product of these two. So that f of u and v is that. So f of x and y, that would be equal to 1/8 into x square minus y square. So option C is correct. Our next problem. If f of x plus y is equal to fx minus fy for all real x and y. For all real x and y, fx plus y is equal to fx minus fy. Then the value of f3 minus f1 is options 0, 1, 2, and 8. So we have to find out the values of f3 and f1 from this identity. Now putting x is equal to 2 and y is equal to 1, we get the equation is f3 is equal to f2 minus f1. Next, put x is equal to 1, y is equal to 2. Again, this is 1 plus 2, that is 3. f3 is equal to f1, x is now 1, minus f2. So adding these two, we get f1 cancels, f2 cancels. 2f3 is equal to 0. So that f3 is equal to 0. We get f3, value of f3 we get. Next, if f3 is equal to 0, from this we get 0 is equal to f2 minus f1. That is, f1 is equal to f2. So next, let us put x is equal to 1, y is equal to 1. This become f2 is equal to f1 minus f1. Both x and y are 1. So f1 minus f1 is equal to 0. So f2 is equal to 0. If f2 is equal to 0, f1 also 0. So we get f3 0, f2 0, f1 0. So that the value of f3 minus f1, 0 minus 0 is equal to 0. So first option is correct. Now, our next problem. The inverse function of fx is equal to 3 sine 4x plus 4 cos 4x is inverse function of that. Options 1 by 4 sine inverse x by 5 minus alpha. Then second option is 1 by 5 sine inverse x by 4 minus alpha. Next, 1 by 5 sine inverse x by 3 minus alpha. And last one is 1 by 4 sine inverse x by 10 minus alpha, where tan alpha is equal to 4 by, most likely 4 by 3. So Let us follow the problem. Fx is equal to that, we have to find its inverse. If I say this is equal to y is given in terms of x. Inverse function is we have to find x in terms of y. Then for that purpose, this can be written as LCM of we combine sin 4x and cos 4x in single variable function like either sin x, sin of something or cos of something. For that purpose, I divide and multiply by 5 throughout. To the linear combination of sin 4x and cos 4x. So this is the technique to combine them. If you take 3 by 5, this 3 by 5 is equal to cos alpha, and 4 by 5 is equal to sin alpha. That is tan alpha. We have taken tan alpha, this by that is equal to this by that, that is 4 by 3. So this become 5 into sin 4x cos alpha plus cos 4x into sin alpha. Sin alpha is this. So that it is equal to 5 into sin of 4x plus alpha. Sin of 4x plus now y is now expressed in terms of x and alpha. Alpha is constant. Now from there we have to find x in terms of y. For that purpose, y by 5 is equal to sin of 4x plus alpha. That is 4x plus alpha, this one, is equal to sin inverse y by 5. That is 4x, that is x 4x is equal to sin inverse y by 5 minus alpha. This is your 4x. So x is equal to 1 by 4 into that, where alpha is such that tan alpha is equal to 4 by 3. Just now we obtained. So the inverse function is that we have to express y in terms of x. That is, function is 1 by 4 sin inverse x by 5 minus alpha. So I think first option is correct. Now next problem. If g of fx, composition function, is equal to e to the power 2x plus 2 e to the power x plus 2, then and fx is equal to root over of e to the power x plus 1, then g of minus 1, options 4 square 2 e plus 1. These are the options. It is a composition function. Function is original function is g and it is argument is fx. What is fx? Now fx is equal to root over of e to the power x plus 1. So we have to first express this as a function of root over e to the power x plus 1. Now this can be written as e to the power x plus 1 whole square. That is, we have taken e to the power 2x plus 1 plus 2 e to the power x. So for adjustment, this is 1. So that it is equal to e to the power x plus 1 root of that whole to the power 4 plus 1. So that g of fx is equal to root over of e to the power x plus 1 whole to the power 4 plus 1. It is g of fx means fx is equal to that. So we can write it as g of root over of e to the power x plus 1 is equal to this. We have to find g of minus 1. So for this, we have to write minus 1. So g of minus 1 is equal to minus 1 to the power 4 plus 1. So that it is 2. So that option is correct. Next. The domain of definition of fx is equal to (1 minus x square plus x to the power 4 minus x to the power 6 up to minus x to the power 14 whole to the power minus half. We have to find the domain of definition of that. Options minus 1, 1. Minus 1 less than x less than 1. 0 less than x less than or equal to 1. And minus infinity less than x less than plus infinity. So we have to find domain of definition. Try to remember that domain of definition means the values of collection of values of x for which the function is defined. For that purpose, we simplify it. Actually, 1 minus x square plus x to the power 4 minus x to the power 14. This is a finite series whose common ratio they are in GP, and GP and common ratio is minus x square. So that its sum is equal to 1 first term minus next higher term. It is minus x to the power 14. Next higher term will be x to the power 16 divided by 1 minus common ratio. Common ratio is minus x square. So that 1 minus this. So this is equal to that. So fx is equal to this to the power minus half. So 1 plus x square by 1 plus x to the power 16 to the power plus half. Change so that it is equal to root over of 1 plus x square by 1 plus x to the power 16. Now you see, this is an algebraic function, this is also algebraic function, and there is no chance that this become 0. So the algebraic function is defined everywhere for finite value of x. So this is defined. This is because once again I am discussing, this is positive, all are positive. So root over of positive is defined. Second thing, we have to see whether it become infinity or not. It would be infinity if this becomes 0. So no chance is there because 1 plus x to the power 16 cannot be 0. So for all finite value of x, this is defined. So this is correct option. Next, the domain of definition of fx is equal to root over of cos inverse 1 minus mod x divided by 2. Options, the options are minus 3, 3, first bracket, minus 3, 3, third bracket, means closed interval, minus 2, 2, closed, and minus 1, 1, closed. So it is basically square root number 1 and inverse function cos inverse x. We know that cos inverse x is defined, it is defined if minus 1 less than or equal to x less than or equal to 1. So here we get 1 minus mod x by 2 is less than or equal to 1. That is, this lies between minus 1 and plus 1. Argument of cos inverse function, this. And from there, second part, we get 1 minus mod x is less than or equal to 1. That is, mod x is greater than or equal to 0. Oh, it is 2, sorry, very sorry. It is 2. So mod x is greater than or equal to minus 1. The mod x is greater than or equal to minus 1, it is obvious. And it is positive, must be greater than that. And I get it from that. Now from this, first and second, minus 2 is less than or equal to 1 minus mod x. So that we get mod x is less than or equal to 3. So when mod x is less than or equal to 3, this is defined. So minus 3 less than or equal to x less than or equal to 3. So this is the correct option. Okay. Yes. Now the next problem. The function fx is equal to sec of log of x plus root over 1 plus x square Now this function fx is equal to that is option odd function, even function, next neither odd nor even, and last one is constant function. That problem was given in so we have to test whether this function is odd or even. That is, we neither odd nor even and constant. So first of all, let us try whether it is odd or even. Fx is equal to sec of log of x plus root over 1 plus x square. F of minus x, calculate for f of minus x. If fx is equal to f minus x, this is even. If fx is equal to minus of f of minus x, then it is odd. So from there, we can calculate first three options. So this is equal to sec of log of minus x plus root over 1 plus minus x whole square is equal to sec log of multiply numerator and denominator by negative of this, that is minus x minus 1 plus x plus root over of 1 plus x square, and this is there already there. So divided by, actually we have multiplied in numerator by that, so for balance this it is equal to sec of log of, in numerator a plus b into a minus b, so it is a square minus b square divided by 1 plus x square. This cancels, so that it is sec of log of 1 by that it is equal to sec of log of 1 by x means minus log of x minus log of x plus, but as because it is sec function, sec of minus theta is sec theta, so that it is equal to sec of log of x plus root over 1 plus x square This is simply nothing but fx, so that we get f of minus x is equal to fx. So the function is even function. Now, next problem. Total number of 1, 1 and into mapping from A, A1, A2, A3, A4 to B is equal to B1, B2 up to B7 is 400, 500, 520, 840, 840, and that problem was given in WB JEE in the year 13. Okay, let us see what is the problem. Two sets are given. First set A is equal to A1, A2, A3, A4. 4 elements are there. And B set, 7 elements are there. One mapping is defined. What is that? How many 1, 1 and into mapping. 1, 1 means 1 versus 1, and into mapping means within that. So, at least some may not be used here. That is, but all mapping will be within that. So, how many such are possible? So, suppose A1 is mapped, it can be mapped to either B1 or B2 or B7. So, the first element A1 can be mapped 7 ways. As because it is 1, 1, so 1 is engaged for A1, 6 are left. Then for A2, there are 6 possibilities that A2 can go to any 6 of the remained, so that it is equal to 6. After these two, 5 elements are left, so A3 can go to 5 elements, and the same way A4 can go to 4 elements, so that it is equal to 20, 42, so 840. So D, option D is correct. Okay. Today is up to this. You share it, like it, and of course subscribe it. Okay, thank you.